Geometry Common Core, the June 2016 Regents exam, starting on number 17. In the diagram below, DB and AF intersect at point C, and AD and FBE are drawn. If AC is 6, DC 4, FC 15, angle D 65, angle CBE 115, which is all labeled for us, which was nice. What is the length of CB? So this is kind of what we're looking for right there. Well, the trick to this question is recognizing that why are they giving us the 65 degrees and 115? Well, if this is 115, then this is 65. And these angles are, of course, congruent because they're called vertical angles, and these 65s are congruent, which means that these two triangles are similar. And when triangles are similar, similar triangles have proportionate sides. And so this will allow us to create a proportion to solve for x. We just need to know what is proportionate to what. Well, I already marked off those angles, so then I'll mark off these in green. Those are obviously corresponding angles. Plus, these 65s also tell us that these are parallel, so we get the whole alternate interior angles situation here. So what does this x correspond to? Well, it's between the single blue and double blue. Between single blue and double blue is 4. And between single blue and green is 6. Between single blue and green is 15. So those are your corresponding sides. Your proportion can be set up in one of two ways. Or actually probably more than two ways. But typically, at the core, one of two ways. I could say, x corresponds to 4. Big triangle to small triangle. Some people like to go small or large, but it doesn't really matter as long as you're consistent. If I'm going big to small x to 4, I got to go big to small 15 for the big corresponds to 6 for the small. The other option is, so this is like 1 from each triangle and 1 from each triangle. Or I could do 2 from one triangle, like 4 over 6 from the small triangle corresponds to x over 15 of the big triangle. So 2 from one, 2 from the other, or 1 from each, 1 from each. It doesn't really matter. If you look at it, at a quick glance, they look different. But when I cross multiply, it's 6 times x. When I cross multiply, 6 times x. 4 times 15, 4 times 15. So it's the same proportion either way. 6 times x, 4 times 15. 4 times 15 would be 60. Divide by 6, and x equals 10. So BC equals 10. Choice A. Okay, so this is 17, number 18. Seawater contains approximately 1.2 ounces of salt per liter on average. So 1.2 ounces of salt per liter on average. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? So they're giving us ounces and liters, but they want us to convert it to gallons and pounds. So again, it's going to be a proportion question. I would say 1.2 ounces per 1 liter. And I want to know, well, what is that in pounds and gallons? So we got to do a little conversion here. Now, they do give you both of these conversions on your reference sheet. I don't think I have the reference sheet built into this file, so I'll just actually, let me just pull it up online for you real quick so you can see what we're talking about here. Where's Explorer? There we go. Let's see. Sorry, I'm going to have to change the layout real quick. And so let's say NY Regents, actually they call it a formula. Yeah, the one for geometry. It's the same for all the exams. So here we go. I think I have this file saved too somewhere. So here's your reference sheets. This is what they give you for the Algebra 1 Regents, Geometry Regents, and Algebra 2 Regents exam. For geometry, really, it's these area volume formulas that are mostly useful. This is more of the Algebra 1, Algebra 2 side. But this conversion up here is what this question needs. And so we're talking about pounds and ounces. So this, I'm trying to highlight that, but you see pounds is 16 ounces. and also gallons and liters. So 1 liter is 0.264 gallons, and 1 pound is 16 ounces. And so that's really what we're using here. So let me head back now to our page here. There we go. So that reference sheet said that 1 liter equaled 0.264 gallons, and 1 pound is 16 ounces. All right, so 1 liter, if I want to convert to gallons, that's pretty easy. That's just the 0.264. But how many ounces is in pounds? Well, 1 pound is 16 ounces, so what I would need to do is divide by 16 to see how many pounds it is. I'm not going to times 16 and say that 1.2 ounces is like 18 pounds. That doesn't really make sense. But you could always do a separate conversion of, say, 1 pound is 16 ounces. Well, how many pounds is 1.2 ounces, and kind of cross. But it ends up being divided by 16. So 1.2 divided by 16 is 0.075. 0.075. And so what we see here is that's now in pounds and gallons. They then ask, they want to know, it's the nearest gallon, how many gallons would it be if you had 1 pound? So now I'm cross multiplying with this. So I end up with 0.075x equals 1 times 0.264 divide by the 0.075, 0.075. So I'm dividing these things. So 0.264, 0.264 divided by that 0.075 is 3.52. which of course will round to 3.5. All right, number 19. Line segment EA is a perpendicular bisector, so perpendicular and bisector of ZT. ZE and ZT are drawn. Which conclusions cannot be drawn? Does EA automatically bisect ZET? Is triangle EZT equilateral? So we got a couple things to explore here. Well, what else can we say from this? We know this is congruent, this is congruent. We could also say this is congruent to itself, which means that these two triangles here, this triangle and this triangle, are congruent. And if those triangles are congruent because of a side angle side congruency, right? A side angle and a reflexive side, that means all corresponding parts are congruent, right? C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So these angles are going to be congruent. These sides are going to be congruent. And these angles are going to be congruent to each other. So true, false. Check all choices. We want not proven. So EA bisects angle ZET. This angle is definitely being bisected because it's got two equal parts, so that is true. Triangle EZT is equilateral. Well, I know it's isosceles because these sides are congruent, but there's nothing telling me these sides are also congruent to this side, so I believe that to be false, but I'll keep going. EA is a median. Medians go from angle to midpoint, and this is going from an angle to a midpoint because it's bisecting, so that's of course true. Angle Z is congruent to T. That of course is also true, so it's that one. It's all about taking the information they give you and what else can you extrapolate from that, and check your choices. Be careful. Number 20. A hemisphere, half a sphere. A hemisphere tank has an inside diameter of 10 feet. If the water has a density of 62.4 pounds per cubic foot, so in the same unit there, you always want to double check that unit, make sure you don't have a conversion. What is the weight of the water in a full tank to the nearest pound? Well, density equals mass divided by volume. And so we have density. We can use the diameter and the fact that it's a hemisphere to figure out the volume, and then cross multiply to find the mass. And when they say weight here, they mean mass. As an astronomy fan, that kind of bothers me that they're using those as the same thing, but we'll get past that. So the volume formula for a hemisphere, they do not give you the volume formula for a hemisphere, but they do give you a sphere volume, which is 4/3 pi r cubed. Now, of course, with a diameter of 10, that means the radius is 5. They always love to give diameter when you need radius. But that's a full sphere, so we're going to have to divide that by 2. You could do half of 4/3 and just make it 2/3, but I'll divide the whole thing by 2 because that's what I think most people will do here. So the volume is 4/3 pi 5 cubed divided by 2. And let's see what this works out to be. So 4/3 pi 5 cubed. Again, get my calculator up. We could do 4/3 of, actually, let me use my fraction template here. Alpha y equals enter is the best way to get the fraction template, and I could do then 4/3. I could have done another fraction for that, but here it won't matter. Times 5. Make sure you always have things like that in parentheses when they have exponents, cubed, and I'm dividing the whole thing by 2. So 261.799, so on. And I'm going to write 261.799, but I'm not going to round that. I'm just going to approximate it. 261.799. So when I use my formula here, density is mass over volume. That's 62.4 equals mass divided by the volume, 261.799. I like to put little dots on the end to remind myself that that's not the whole number. There are more numbers after that. But anyways, just cross multiply here. Multiply these together to find the mass, which they're calling weight. But again, I'm going to use the exact answer in my calculator, so I'm not rounding and just hitting times 62.4. Just want to double check it's 62.4. Yes. And, sorry, I wanted to go back to the calculator. The mass is 16,336. The mass equals 16,336, which they are saying is the weight. All right, we reached the 13-minute mark, so I'm going to stop here at 20. We'll pick up on 21 for the next video. See ya.